Namaskaram and welcome to today's video where we're going to be discussing one of the four fundamental forces. Today I'd like to highlight electromagnetism, which may sound like a daunting term, but it's actually something we use on a day-to-day basis. From the colors that you see around you to the simple utilization of light. Electromagnetism is behind it. And basically what this force is, in layman's term, at the very foundation of physical reality, we have these little bits, these units called atoms, which are composed of protons, neutrons, and electrons, which have a positive charge, a neutral charge, and a negative charge. And if you've ever played with magnets, you may know that one end of the magnet will repel each other, whereas two ends of them will stick together. What this is an example of electromagnetic force. Whenever there are the negative particles, the electrons, moving around in space, they are going to offset the total charge of that particular atom or molecule, which is a composition of multiple atoms. And whenever something is negatively charged, that means it has more electrons. And whenever something is positively charged, it means that it has more protons. So, whenever these forces are in movement, the electrons have a lot of freedom to go to and from atoms based on the charge. So if something is positively charged, the electrons, which are negatively charged, are going to go towards it, just like a magnet does. And basically on a fundamental level, these atoms are creating a magnetic field. And actually, not just magnets do this, but Earth itself, in its core, has molten metal, which is basically hot lava. And the churning of the hot lava, the movement of it, creates an electromagnetic force field around Earth, which sounds science fiction, but it's totally true. And this magical force field, which is created by electromagnetism, actually shields our Earth from harmful UV radiation that's caused by the sun. The amplitude or the force or the power behind an electromagnetic force is going to be measured by the amplitude or the vibration of its wavelength. So whenever we have really slow moving waves that are far in between each other, that's going to have a much lower resonance versus a very short wavelength that's moving more quickly. On the slower end of the scale, we're going to see things like radio and TV. And then after that, we have the measurement of infrared rays. And microwaves. And then, so microwaves are basically what cook your food. And then beyond microwaves are infrared waves. And infrared is the spectrum of light that we can't see. Beyond infrared, however, is this very small window called the visible light spectrum, and that composes everything that you see. Every color, every wavelength that you could even imagine is within this small range of the electromagnetic scale. Beyond the visible spectrum is ultraviolet light, or UV. Maybe you've heard your mom telling you that you need to put on sunscreen to protect you from UV rays. Beyond that is X-rays, and beyond even that is something called gamma rays. The shorter the wavelength of the electromagnetic force means that it's able to actually pass through the human body, which is one reason why the UV is actually very damaging for the skin. It passes through it. So UV, X-ray, and gamma are actually very applicable in the medical field. Thank you so much for your time. I hope that this answered some of your questions on the electromagnetic force. Have a great day.